This is Unit 2, number 5. So this is a situation graph problem. We're trying to figure out which of the following represents the relationships of speed and time elapsed. So the first thing you're going to need to do is determine what two variables are being compared, which you're going to look on your axis labels. So in this case, on this number, we're looking at time and we're looking at speed. Okay, that changes a lot of things when you're thinking about what you're thinking here. So remember, we're doing speed, not distance. Now we're going to separate your graph into pieces and determine what is happening. What I mean by that is you look and you kind of think, where is this thing changing? So if, for instance, I had a CBR graph that looked kind of like this one, I would look and say that I have a chunk right here. Everything changed after this point. I have a little chunk right here, and then I have a chunk here. And I would go and talk about what do all of these pieces mean individually. So I'm going to go ahead and do that on number 5. So if I'm looking at the beginning of number 5, I think I have about 2 or 3 chunks here. The first chunk I have is this piece. And this right here is going up. The speed is increasing. Okay, someone's getting faster. Then we're going to go to the second part of my graph where the graph is going down, and that's where my speed is decreasing, or I'm going slower. The last important piece of this graph is this part right here, where all of a sudden I have 0 speed. Well, if you have 0 speed, then you're not moving, you've stopped. So now at this point, I could go through and look at each of my answer choices carefully and figure out what's happening in each answer choice to see if it matches what my graph is going on. So if Carol is riding her bike steadily up the street, takes a break, and then rides back. If she's riding steadily, that means her speed is constant. Her speed is not changing. My graph doesn't show that. Mine says that I'm going faster. So it's not A. Your other hint here is that she takes a break in the middle. She's going to have 0 speed in the middle and then ride back, and that would be increasing. That's nothing like my graph looks. Okay, letter B. A woman climbs a hill at a steady pace. Again, this would be a constant, or that flat line, and then starts to run down one side. When you run down a side of a hill, you get faster. Not what my graph is doing. Letter C. Mike runs up a hill, and as you run up a hill, you're going to start getting slower and slower and slower as you go steeper up that hill. So he's going to go slower, and then he's going to hit the top and run back down. When you run down a hill, you start going faster and faster and faster. Remember when you rolled down the hill when you were younger. Okay, so that would be slow, then fast. Ours goes fast, then slow. It's not letter C. Must be letter D. If he rides down a hill, he's going to be going faster first. That looks good. Then he's going to slowly come to a stop. So if he's slowly coming to a stop, then that means he's going to slow down, slower, and then he should hit 0 speed. So the answer choice here is letter D.